All right, so I got a request for a rapid fire 5 on completing the square, so I thought I'd just do, I think probably 2 minutes of talking about the history behind it. And then, or at least what I think it is. And then I'll just do 5 problems in a row quickly. Okay, so hopefully 2 minutes from now, we get to doing 5 problems quickly. All right, completing the square. So x squared minus 12x plus 32 is a algebra 1 trinomial that you usually get something like that to practice your factoring skills. You know, finding the numbers in general that multiply out to be the trinomial. And completing the square is going to allow us to get a calculation. This has got 3 aspects to it. We're going to write it so it only has 2, which means we can process things a little more quickly, compute things a little more quickly. And it also has the benefits of giving a sense of what the graph looks like and being able to solve equations more quickly than if we have this equal to something that's not user friendly. All right, so what's it mean to complete the square? Again, I don't know where that term came from, but it's to take this kind of configuration and reshape the geometry of it. And to do that, you've got to even off the sides. So this would be x minus 6, this would be x minus 6. If I multiply this out, I've got x squared minus 12x plus 36. And we want 32. So I guess I complete the square by saying minus 4. You know, what have I completed? I've completed the fact that y, my area, why don't I write area A? My areas could have come from either x squared minus 12x plus 32, or I could rewrite it now as x minus 6 squared minus 4. What are the benefits to this? Well, if I said, let this area equals 29, for instance, well, I can't bring 29 over, set it to 0 and solve by factoring. Whereas over here, setting it to 29, well, that's a piece of cake. All I got to do is add 4, 33, take the plus minus square root of 33, no deal. Maybe you want to remember plus minus, and then bring the 4 over and bang. Not much to that. Right? So I can get quick answers by putting it into this form. I can also see cup shape up. I can see the vertex. Why can I see the vertex? Because the smallest area that a square can be is 0, right? And 6 makes that, and positive 6 makes that. Why did I say negative? Sorry, positive 6 makes that happen. So I've got some knowledge about the smallest outcome of this trinomial. So there's some benefits. All right, so there's my 2-minute spiel. Now I'm just going to take 1, 2, 3. I'm going to do 4 of those in graphing form, which is really what completing the square is all about. I'll show you the quickest way to do it. And I'll show you the way that most students do it successfully. So the quickest way might work for you, might not. The other way is generally something that everybody can pick up. So 2x squared minus 12x plus 5. And we're going to look at the graphs, you know, 2x squared minus 12x plus 5. We're going to learn how to add up things from a graphical standpoint in our discussions on the cubic. So that's coming. Over here, we only have to draw 2 pictures. And so we'll elaborate on that later. All right, so I'm trying to put 2x squared minus 12x plus 5. I'm going to rewrite that as a square. I'm going to do it the way I like to do it. I know that a 0 gets you 5 here. I can just see that. So if they're opposites, I know it's a negative. All I have to do is divide 2 into 12, 6, cut it in half, 3. Now, when I square this, I get 18. I don't want 18. I get rid of it. I want 5. And there's our completed process. And I don't think I had to think. So that's what we'd work with. If we wanted to solve that for a number, we could do it. If we wanted to graph it really quickly, we could do it. So a lot of quick information here. And 0, 5's on this side. So there's a lot we can do with it and do it quickly. Now, that's what I like to do. Of course, that's minus 13, right? You have to doctor that up at the end. What's the method that you've been using most often? Minus b over 2a. So minus b over 2a, in this case, it's positive 12 over 4, which is 3. So that's why you say x minus 3, because there's a minimum here. And there's a minimum, we talked about that before, when you get rid of the area. So when you drop a 3 in here, there's no area, you're going to get that adjustment over here. All right, so once we find out that it's 3, we can write that immediately. And then we've been having you drop 3 into the function because that's going to get the y value that goes with it. And so there you got 18. The next one's negative 36 without looking. Plus 5. When you add the first 2 terms, you always get half the middle term. Plus 5. And there we are again. Minus 18 plus 5. Getting to the same place from a different procedure. There's minus 13. That's the method that you've been practicing the most. So I'll do both since we've got 4 problems. Remember, you're pausing the video and you're trying on your own. All right, so minus 4x squared plus 8x minus 2. I'm going to write it my way. Minus 4x, opposites again, so it's negative. 4 into 8, 2 cut in half is 1. Minus 1 squared is 1, negative 4. I don't want that number. I'll get rid of negative 4. I want negative 2. And I'm done. So there's your minus 4x minus 1 squared. 4 minus 2 is plus 2. And I can set that to numbers and solve very easily. I can graph. That's got a maximum of 2 and a vertex of 1, 2. All right, so what way are you doing it? You're doing minus b over 2a minus 8 over negative 8, which again is 1. So that gets us the 4x minus 1 squared. Then you're dropping 1 into the equation. That's minus 4 plus 8 minus 2. Again, that's half. Adding those things up is always half. Oh, positive 4, excuse me. Positive 4 minus 2. There's your positive 2, which we said a minute ago, and I erased it, I guess. Oh, no, it's up here. There it is. All right, so there's your calculation. It used to look like this, and now it looks like that. That's got a lot of benefits. All right, 3x squared plus 30x minus 7. 3x squared plus 30x minus 7. How do I do it? Well, I take the, that gets me the first term. They're both positive, so I know this is a positive. I divide 3 into 30, 10. I cut in half, it's 5. That's 75. I don't want 75, because if I put a 0 in, I get negative 7. If I put a 0 in here, I get 75. I don't want that. I want negative 7. All right, so I can see this has got a minimum y-intercept at 0, negative 7 on the upside. So that's 0, negative 7, and I'm looking at negative 5, negative 82. How are you going to do it? If you don't see my way, you're going to take 3x squared plus 30x. I'm going to get rid of that. And you're going to do what? You're going to do minus b over 2a, which I hope you remember for a long time. Minus 30 over 6 is minus 5. It's minus 5. You're going to write plus 5 so that you can minimize the area by making the area 0 squared. That's what you're telling the reader. And so I put negative 5 into the equation. If you put negative 5 into the equation, you get 75 minus 150. There's our 2 to 1. So that means all I have to do is cut that in half. Minus 75 minus 7. We've been there before. Negative 82. Sorry, I meant to write it here. All right, and there you go. Lots of information. Again, you can solve that really easy. I'll make that equal 100. If I make it equal to 100, I'm going to add 82. I'm going to divide by 3. I'm going to take the plus minus, and I'm going to bring the 5 over, boom, roots. Whereas if I set this thing to whatever number I just said it was, I don't know what I even said. Let's say 27 this time. That's nasty. That's not fun to do. All right, next one. Minus x squared plus 4x plus 10. All right, my method is a minus x. I know I got that. They're opposites, so negative. Minus 1, so I just got to do 1 into 4. 4 cut in half is 2. 2 squared is 4 with a negative sign is minus 4. I don't want minus 4. I'll get rid of minus 4. I want positive 10 because if I put a 0 in, I get 10. So there's my graph. Cup shape down. 16 is the max. Happens when x is 2. So therefore 0, 10 is on this side, which we knew anyway it was on the increasing side. How would you do this problem? Minus b over 2a. Minus b over 2 times negative 1. Well, it looks like 2 to me. You're going to plug 2 in. That gets you minus 4 plus 8 plus 10. That gets you 4 plus 10. That gets you 14. I hope that's what we had before. So that's minus x minus 2 squared plus 14. There's the graphing form. You can set it to any number you want. Solve that to get x alone pretty easily with subtraction, division by a negative, plus minus square root. All right, so that's a little work on completing the square. Again, why do they call it completing the square? I don't know. Somebody did, long time ago. We're stuck with it. Wish it was called something else.